So welcome back students to one more session of your structure of atom. Still now what did we discuss? We have discussed the index of structure of atom. Gradually I've taught you three different topics in the chapter. What were they? First were the cathode ray experiment. So after that I've taught you what is the concept of E by M ratio. Who has given us this concept? J.J Thomson, isn't it? After that E by M ratio I've taken you all into a concept called calculation of charge, that is by Millikan oil drop experiment. Then I've also taught you how is the mass calculated. So finally we have come to a complete conclusion of the topic, that is of cathode ray, right? And after cathode ray I've taken you all into a topic called anode rays or canal rays, isn't it? So that is where cathode rays are. Cathode rays, they consist of electrons, anode ray, they consist of protons, and then from the protons I've taken you all into a discovery of neutron by Chadwick. All the three topics are completed. Now gradually we'll go into a concept called atomic models of an atom. In that, the first model is Thomson's model of an atom. So J.J Thomson already given us the E by M ratio, but here he has given us a complete an analysis of an atom. J.J Thomson has discovered the atomic model, has given his observation in the year 1904. Right, so when he started, or he is given this model of an atom under the name. So first he has named this particular model, or his model, as called as plum pudding model. Okay, plum pudding model. He has also given, or it is also called as, you have studied the same in grade 10th also in some of the state board books. It's also called as watermelon model. Fine, this is nothing big in this watermelon model. Yes, he is also called this as raisin pudding model. Raisins means in that particular cake, raisins, that is your dry fruits, isn't it? Raisin pudding model. But what is important in this, he has said that first, before the discovery, before the conclusions, coming to the conclusions of the atom, after naming the particular model, he has used the word corpuscles. That is the first most important. Thomson, when he started discovering his model, he said, or he has used the word called corpuscles. This is what is the word. Corpuscles is a word used by J.J Thomson. And he the other word, that is your electron, was used by G.J. Stoney. This is what is this minor difference. That's fine. Then what did he say about the atom? What was his observations of the atom? He said, when he started, he said, first of all, okay, let us draw the diagram. This is your whole spherical atom. Then I said the whole atom, or the whole sphere of the atom, is evenly spread by the positively charged space. This is the whole thing, he said, it is evenly spread by a positive charge. So that is the first assumption of your J.J Thomson. So what did he say? Atom consists of evenly spread. This is a rough diagram which I have drawn. Evenly spread positive charge. Okay, this is done. After that, he said, in between, or in the space, this is whole evenly spread positive charge, and in this positive charge are embedded negatively charged electrons. So the negatively charged electrons are embedded in this way. So let us write that also. Negatively charged electrons are embedded. Right. This is also fine. Embedded means they are sunk in the positive charge. After that, he said, when I take the whole atom with the positive charge and negative charge, the overall charge of the atom is neutral. That is why he said atom is electrically neutral. Let us write that also, because both are balanced. So atom is electrically neutral. This is what is the assumption of this, of Thomson. First thing, he said, or he's compared the model of an atom with plum pudding model, just like your cake where you have all the raisins attached, all the raisins, dry fruits which are incorporated. The whole mass of the cake is compared to the positive charge, as well as all the dry fruits in that are compared to the negatively charged electrons. When it comes to watermelon, it is the same case. The red pulp present in the watermelon is compared to your positive charge, and the black seeds are compared to the negatively charged electrons. Now here raisins also are the same. The whole cake, again the mass of the whole cake is compared to the positive charge, as well as the raisins or the dry fruits are compared to the negative charge. But what is important, that is okay, that you can all write, but what is important is corpuscles. He has called the electrons as corpuscles. Then came J.J Stoney, then he has used the term electrons. It is not Thomson who has used, it was Stoney who has used the word electrons. But his whole concept was only two important things, or let us say three important things. First, it is evenly spread. The positive charge is evenly spread. In that positive charge, what do we have? We have electrons which are spread. Now when I compare between the positive and negatively charged, what is important? Atom on the whole is electrically neutral. But what made this model failure? What are the failures of this? Basically, when I have to speak, or when after the discovery of Thomson, Rutherford alpha ray scattering experiment came into picture, isn't it? In the late 19th century. So then Rutherford has given a lot of observations on the model of an atom. That particular observations Thomson could not explain. That was a major failure of Thomson. So let us write that Thomson could not explain Rutherford's observations. So this is simplest Thomson's model, nothing big. You will be asked for 2 marks or something. This is important. These 3 categories or these 3 assumptions or observations are very, very important. Now let's come back and start with your Rutherford's alpha ray scattering experiment. We'll be learning its observations, we'll be learning its conclusions, we'll also be learning the failure of Rutherford's model. Right. So now after your Thomson's atomic model, next came into picture your Rutherford's alpha ray scattering experiment. So basically Rutherford scattering experiment, if I have to say, compared to your failures, the maximum discovery of the whole atom, the nucleus part, or the complete conclusions of the formation of orbits inside the atom, how are the electrons moving inside the atom, all these observations were given by Rutherford. So he has laid his experiment, or has done his experiment in the year 1911. Right. So when we have to see the construction of Rutherford's experiment, basically first, every time whenever you're learning an experiment, see the experimental setup. After the experimental setup, gradually come into a topic called observations. After observations, you need to learn about the assumptions. After learning the assumptions, you should know what are the conclusions. After everything is done, you have to come to a topic called failures. After doing so much of experiment, what are the assumptions he has seen? What are the observations he has given us? But what are the failures still there in the model? So as I said, first is the experimental setup. So when I have to speak about the experimental setup, he has picked up the first thing in Rutherford's experiment. He has picked up a source of alpha ray, right? The fast moving alpha ray, that is nothing but the helium nucleus. So in Rutherford's experiment, what should you write? First of all, he has picked up source of alpha ray, or it is helium nucleus, atomic number 2, mass number 4. After that, picking up the source, he has also taken this particular slit system, right? So 2 slit systems, so that you're allowing the ray to travel in a straight direction. So what is the next construction? He has set up a slit system, so that, why is that? Just now we said, so that alpha ray travels in straight line. Okay, this is also over. After this particular ray, he has provided this next important. For the ray to hit, see, basically we are studying the structure of atom. For that, he has taken a thin gold foil. This is your thin gold foil. So let us write that. Thin gold foil. How much was that? It was, the size of the gold foil was almost approximately 100 nanometers, right? Or 10 to the -5. Okay, 100 nanometers size of the gold foil was taken. The thin gold foil had 12,000 atoms present, electrons present in that, atoms present in that, which are incorporated. So this thin gold foil was fixed at one end of the setup. After that, he has taken just see here, I'm talking about this part. This is a circular fluorescent screen. So what should you say? Circular fluorescent screen. Why is this circular fluorescence screen taken? Because whenever alpha ray comes and hits this gold foil, it has shown, or how do you study that particular scintillations? You are going to, unless until you place a screen, you will not find the scintillations, isn't it? So circular fluorescence screen, in the bracket you can write, to observe scintillations, just your points. Just like scintillations means when you take a particular, when there's a metal sheet present in front of you, you're throwing stones on the metal sheet, you will get different marks on that particular sheet, isn't it? Those marks, or that particular, if a light passes, those are called scintillations. So circular fluorescence screen, to what? To observe scintillations, SCIN, scintillations. Important. Yes. Now what is this particular circular fluorescent sheen coated with? It is coated with zinc sulfide. So let us write that. Circular fluorescent screen to observe scintillations is coated with zinc sulfide. Okay, this is also not much big. Yes, fine. After the setup is done, let us see what has he observed. So whenever you are learning Rutherford experiment, always remember, try to write the tabular column with the observations and the conclusions at the same time. Don't write observations once, conclusions once. No, because your time is very less. Given mark is only 3. So you should try to be precise in answering as well as observations. So this is the setup. First point is this. Second point is this. Third point is the gold foil. Fourth point, as I said, it has 12,000 atoms present in that. And the fourth point is your circular fluorescence screen. Why am I using that? To observe scintillations, and it is also coated with zinc sulfide. Now let's come back and see what has he observed. Right, so we have seen the experimental setup. Now let us see what has he observed after performing the experiment. So what did we say? He has taken an alpha source, then he has allowed it to pass in a straight line by taking just a slit, allowed it to pass in a straight line, then allowed it to fall in a gold atom. How much was the size? It was approximately 100 nanometers. So now this is your gold foil. Inside the gold foil, when he has observed the scintillations, he has arranged a circular fluorescent screen, isn't it? So now based on the observations, or based on the scintillations, let us read what are the observations. So now let us make a tabular column in this way and write both the observations and conclusions together. First would be the observations, next would be the conclusions. Right. So what are we observing? When the alpha ray has passed, first some of the alpha rays, most 99% of the alpha ray, if I have to see, they have moved in straight lines, right? So let us write that thing. 99% of the alpha ray has traveled in straight line. So what can I conclude? Based on an atom, I can conclude that most of the atom, or there's a lot of empty space present in the atom. Because of the empty space only, the alpha ray is able to travel in straight line, isn't it? Yes. So let us come to the conclusion. Conclusion is most of the space in atom is empty. This is what is the conclusion. After that, let us come back to the next observation. So when you see this path of the alpha ray, just see here, some of the rays have deflected. Look here, this deflection. Yes, and some of the rays have hit the center and they have deflected in small angles. Let us go on here and come back. So let us write this point first. So what can I write? Here, when the alpha ray is hitting, okay, let us write very few. This is maximum, this is very few. Very few have deflected back. So now what is the reason? Now I said alpha ray is a positively charged species. Now when something is like like in like, they get repelled out, isn't it? So alpha ray is positive and there is certain amount of positive charge present in the center. That is the reason when alpha ray has hit the center mass, because of the like poles, it has deflected back. Both will not see, if it is negatively charged here, it would have gone attracted and gone to the other side. But here what is happening, alpha is also positive charge and the center mass which is present also is positive charge. So let us write that. Very few have deflected back. Now what should I write? Most of the positive charge is concentrated in the center. Right. So now let's come back and see the third point. Now what happened, we have written this point, then we have written this point. Now let us come back and do this, write this point. So here when I see most of the rays, see here, this has come, hit the positive charge and it has come down, isn't it? It is deflected down. What can I write? Right, let us write that. Few alpha particles or alpha rays got, this is very less, this is very few, got deflected. So what can I say? I can say that the positive charge, okay, so the center means the presence of this positive charge is concentrated, or it is located exactly at the center. That is where when the alpha particle hit that, this range, this particular the presence of the positive charge made it deflect down. So there's a little bit difference between second point and third point. Let us write. So atom has positive charge present. Right. So these are the observations and conclusions. Now let's come back and see the nuclear model of an atom. What actually has us concluded with the whole concept of Rutherford. Right. So after performing the experiment, then gradually he has given the observations and conclusions. Then finally he has come to a concept called nuclear model of the atom. These were the final observation or final postulates of the experiment. So now what did he say? He has got an idea. Okay, there's a positive charge present. Then there's a lot of space present. Then again he spoke there are electrons present. That is from J.J Thomson. Altogether the Thomson's assumptions as well as Rutherford's assumptions, they were put under postulates. The first important postulate which Rutherford gave is, so what did he say? Most of the mass of an atom, this is what he said, isn't it? In an atom, the center part is positive. That is why alpha ray deflected and reflected also back, isn't it? So the first assumption which he gave is atom consists of positive charge concentrated in the center. This is the first important thing. But here, next important, what did he say? This positive charge or the area where the proton is present, that is called the nucleus, right? So he said the size of this nucleus or compared to the size of the atom is smaller. That is the next important thing. What did he say? Size of, just now we said it is concentrated in the center. That means the area occupied is very small, isn't it? So size of the nucleus is smaller than, I think there's some mistake, okay, smaller than size of atom. So how much is this? When I see size of the nucleus, it is 10 raised to the power of minus 15. When I see the size of the atom, it is 10 raised to the power of minus 10. So compared to the this one is 10 raised to the power of minus 15. This is 10 raised to the power of minus 10. Smaller, isn't it? Yeah. The next important thing he said is, now this is over, here's compared. But what did Thomson say? He said the certain amount of electrons, negatively charged electrons, isn't it? Now these electrons, now this is where is the concept of Rutherford existing. He said the negatively charged electron, right? They are they continuously move or rotate around the nucleus, isn't it? Fine. So he has used negatively charged electrons continuously accelerate. This is what is the word which you have which you have to use. Then only you can see there's certain terms which you're supposed to use in the answer. You can't write it by your own, isn't it? These are all the postulates given by Rutherford. So negatively charged electrons continuously accelerate around nucleus. Okay, around nucleus. This is also fine. Now after that he said, I'm writing this nucleus spelling wrong. Okay, around the nucleus is it. Now after this concept, he just came to a next important information. Thus these electrons are traveling in orbits. This orbits concept was proposed by Bohr actually. So they said it's moving in certain orbits. So electrons travel in certain orbits. But he has not named the orbits as KLM shells like Bohr. He has just given this word. Next, he concentrated. Okay, let us erase this part. After the certain orbit concept, then he spoke. Now see, always whenever certain negative and positive charge are rotating, that means a certain amount of electrostatic force of attraction existing. Until there is a force of attraction between those two, the electron will not stand there and the positive charge will not be here, isn't it? So what did he say? He said electrostatic force of attraction means charge between oppositely charged particles. Attraction exists between electrons and protons. Exists between electrons and protons. Okay, so I have written E minus here. Let me write protons as E plus. Now, when this electrostatic force of attraction, there's a certain amount of centrifugal force also acting, isn't it? The outward in this direction. So you can just conclude electrostatic force is balanced by centrifugal force. You can write this word. Fine, this is also over. So now I spoke about the positive charge. I spoke about the size of the nucleus and size of the atom. Then I spoke about the electrons traveling around the nucleus in orbits, and I also spoke about the electrostatic force. Now comes the total neutrality. You have to be very careful. He has used the word atom is electrically neutral. This is what is, you have to justify that particular thing. Electrically neutral. Why is this electrically neutral? That means the total number of negative charge is balanced by the total number of positive charge. That is what he has given us as a conclusion. So atom neutral means total number of negative charge is equal to total number of positive charge. This is what he has given. Now, last but not the least, after speaking about nucleus, after speaking about electrons, after speaking about electrostatic force, he has finally come to a conclusion saying that atom on the whole has a lot of empty space present in that. That is why, because he didn't know about the concept of K shell, L shell, M shell, N shell as Bohr knew, isn't it? So he didn't even know what is s orbital, where is s orbital, p orbital, nothing of that sort. So he has come to a conclusion saying that most of the space in atom is empty. This is what he said. So this is your nuclear model of the atom. Now after so much of experimental setup, after so much of observations, after so much of postulates, there's certain failures which like very few, like which were later corrected by Bohr. So let's come back and see the failures of Rutherford atomic model. Right. So we have seen the observations, we have seen the conclusion. Now let's come back to the last part of the Rutherford model, that is failures. So whenever a question is given to you, you need to start from the experimental setup and end your answer till here. So now, when we have to speak about the failures in Rutherford's model, nothing much big, but certain considerable failures. What are they? See, whenever we speak about electromagnetic, that's Maxwell's concept of electromagnetic radiations. Let us write. Right. So now what is the concept? Whenever something, see, you're holding a particular, you're standing in the center of the ground. You're holding it, you're holding as a long thread and you're tying a small stone towards the end of that particular thing. Now you started and you're moving it continuously round and round and round. So after some time, when you try to, you're moving and finally leaving it. So what will happen? That particular stone, once till then, it keeps moving, and finally once it loses its energy, it comes back and falls down on the ground, isn't it, due to gravity. Same is the concept. Rutherford's atomic model is also called as planetary model, right? Why? Because he is told electrons keep rotating around the nucleus, just like your solar system where planets keep rotating around the sun, isn't it? So this is also called planetary model if they give you in the exam. Done. So according to Maxwell electromagnetic radiation, the first important thing, whenever there is a fast moving electron just moving around a particular path, it starts emitting radiation, isn't it? When it continuously moves, just like the stone in the thread which I said just now. So just write that first assumption. Fast moving electron tends to emit radiation. And what will happen if it emits radiation? It finally falls into the nucleus and falls into the nucleus. This is the first thing, isn't it? Yes. So next important thing, Rutherford, he could not explain the distribution of electrons in that particular atom. He could not specifically say what are the energy levels present, what are the orbits present. He could not name it. That was the main failure. He could not explain. He just said electrons are moving around the nucleus, but nothing specific about the distribution. So let us write that as a failure. Could not explain the distribution of electrons around the nucleus. Okay, this is also fine. The next important thing, after drop of electron into the nucleus, failure. Distribution of electrons around the nucleus, that also could not be explained. The next important concept is, see, he could not explain the stability. How is the atom stable? If it loses its energy, whether it will fall, or if it is still existing, how is the stability? So the concept of stability will be further learning the stability of the atom also. He could not explain stability of atom. Right. Then the last but not the least, after J.J Thomson, certain improvements were made by Rutherford. After that, Bohr came into existence, and he has explained the hydrogen spectrum. We'll be learning the atomic spectrum in hydrogen, very discrete lines. How are the lines, whether it is emission spectrum or absorption spectrum? That concept of the discrete lines or the concept of spectral lines in hydrogen atom were not or could not be explained to Rutherford. He just gave us an idea. There's a positive charge present, there's an electron present, there's a lot of space present, there's a nucleus present at the center. That is what he said. But the concept of hydrogen spectrum was not explained by Rutherford. So let us write that. Concept of hydrogen spectrum. What was that? Those are the discrete lines which we'll be learning very soon. Discrete lines was not explained. That's it. So these are the failures of Rutherford's atomic model. So remaining all, hope the concepts are clear. Thomson's model, 3 important points. Rutherford's model, experimental setup, observations and failures. Thank you for watching.